This is the second video for section 11.1 covering the back side of the note sheet. In number 5, we're asked to find the area of the 4 rectangles below, and of course we know that the area of a rectangle is the base times the height, but we do not know the base and the height for any of these triangles. So the first one, you got to keep in mind in all of these that we've got 90-degree angles in rectangles, and you'll notice that they're all split with a diagonal, which of course splits it into 2 right triangles. So I can figure out h because I know the hypotenuse of this right triangle as well as one of the legs. And yes, you could do 5 squared plus h squared equals 13 squared and solve for h, but you guys all know at this point that we have a 5, 12, 13 triangle here, so the h must be 12. Therefore, area is base times height. We've got 5 for the base, 12 times the height for the height, which is 60, and that's going to be units squared. Next problem, I have a right triangle that I can help to find, use to help me find h. I have a 30-degree angle here, a 90-degree angle here, which leaves, of course, a 60-degree angle here. And you guys know your 30, 60, 90 triangles really, really well. In fact, you know that the short side here, which is the height, is going to be the hypotenuse times 2, or half the hypotenuse. So 16 divided by 2 is 8. The height is 8. And then you know the base must be the short leg times radical 3. So then the area base times height is 8 times 8 root 3, or 64 root 3 units squared. Next, we have a rectangle very similar to the last problem, almost exactly the same, except instead of the ever so convenient 30 degrees, we only have 25 degrees here. So the numbers are not going to be quite as neat as the previous problem. Alright, so I got to figure out b and h here. To figure out b, I know the adjacent to 25, here's the triangle that I'm considering. I know the b is adjacent and 14 is hypotenuse, so that should be cosine of 25 equals b over 14. And when I solve for b by multiplying by 14 on both sides, I get, let's see, 12.7. H is opposite, so I'm going to choose sine of 25 degrees equals h over 14, and when I multiply 14 on both sides, I get 5.9. I'm going to multiply those two together to get the area of 74.93 units squared. The last one, number 5, same deal. I know the diagonal of my rectangle, and I know one angle is 45 degrees. I know that this angle of my right triangle is 90 degrees, and that leaves 45 left for here. So we know 45, 45, 90 triangles actually have congruent legs here. It's an isosceles triangle. So actually all the sides of this rectangle are equivalent, which actually makes it a square. So we're actually going to use s squared since base and height are the same, but we don't know the side. How do we figure out the side? Well, you memorize in chapter 8 that in a 45, 45, 90 degree triangle, the hypotenuse is equal to the side length times root 2. Now to go backwards, we're not going to multiply, we're going to divide. So here we have 14 over root 2 and 14 over root 2. Now we wouldn't leave 14 over root 2, we would rationalize the denominator. So that gives us 14 root 2 over 2, or 7 root 2. So the base is 7 root 2, the height is 7 root 2. Let's multiply them together, or square the side, which gives us 49 times 4. 7 squared is 49. Root 2 squared is 4. And 49 times 4 is 98. Oh, I'm sorry. I need to go back. that was a mistake on my part. Root 2 squared is not 4. Root 2 times root 2 is 2. And then 49 times 2 is 98 centimeters squared. Oh, and this one back here, I knew that this was centimeters, so I'm going to go back and change that. Thank you for bearing with me here. Number 6, find the areas of the figures below. Alright, so take a look. These are not regular shapes that we've got memorized formulas for. So what we're going to do is we're going to break them up. And there's various ways that you could do this. So if you didn't do it the same way as me, that's fine. But you should get the same answer. So for number 6, I see lots of rectangles. If I break off this top rectangle, we'll call that part number 1. And then break this triangle off. I've got part number 2. And then let's call this triangle 3. Alright. The area of triangle 1, I've got a base of 6 and a height of 1. 6 times 1 is 6. And then area of rectangle 2, you can see I have a height of 4 and a width. Now I'm not sure of the width. It's not directly labeled, but I do know, sorry about that, I do know that this whole base is 6. If let's change to a different color here. Subtract out 2 and 2, then all I have left, 6 minus 2 minus 2, 6 minus 4 only leaves me 2 here. So I know the height is 4 and the base is 2, so the area of space 2 is 4 times 2, or 8. And then let's switch to another color for area of triangle 3. Let's see, again I have a base of 6 and a height of 1, so that's 6. So we're going to add up 6 plus 6 and 8 and get 20, and we'll call that units squared. Next problem. You see a couple of different rectangles here, so I'm going to go ahead and split them off. Okay. For space 1, I see a base of 12 as well as a height of 12, so it's not just a rectangle, it's a square. It's going to be 12 times 12, which is 144. And then down here, I've got let's change to a different color so you can keep track. I've got a base of 12 and a height of 6, so that's the area of 2 is 12 times 6, which is 72. If I add these two together, I get a total of 216 units squared. Alright, next one. Let's see. We can break this up a couple of ways. You could go with horizontal lines like this, if you like. Doesn't have to be that way. You could drop down vertical lines like this. It's up to you. I'll stick with the vertical lines, and I'll call this first space area 1. Okay. Area 1, I've got a base of 4 and a height of 4. It's actually a square, so I've got 16 there. Let's change colors. Green. Space 2. Now I have a base of 4. Height is not immediately clear to me, but if I know that this piece is 4, and then I can borrow this piece and call it 4. 4 plus 4 is a total of 8, so the height is 8, and that gives me 32. And then finally, let's see, space 3, I'll highlight in red, got a base of 6. The height is not immediately clear, but if I know that this is 8, I can borrow it. 4 plus 8 is 12, so my height is 12, and that gives me 72. Now, to get the total area, I'll take 16, 32, and 72 and add all those up, and that ends up giving me 120. And we'll say that's units squared. Alright, a few more problems, then we'll be done. A rectangle has an area of 40. A equals 40. And then we know the area is equal to base times height. So there's one equation. 40 equals base times height. Its width, and you know what? Because we're using width here, let's go ahead and I think some of you have memorized, instead of base times height, we've memorized length times width. It seems like this problem is written with that language instead of base and height. So we'll say width, length times width. And the width is 3 units longer than its height. So 3 units longer than its length, let's say. Alright, find the dimensions of the rectangle. Okay, well, I know the 40. I'm looking for the L, but I have something that I can replace into the W. So why don't I take 3 plus L and plug it in? So that gives me 40 equals L times 3 plus L. Or 40 equals 3L plus L squared. Now that's a quadratic, and the way we solve quadratics is to get everybody on one side, 0 on the other, and then we like it if the square term comes first, the first degree terms come second, and the constant comes last. Now if we can, it's usually easier to factor. So let's see, can we come up with 2 factors of negative 40 that add up to 3? Well, that would be a positive 8 and a negative 5. So plus 8 minus 5. L equals negative 8 and L equals 5. Okay. Now, one of those makes sense as a length, one of them doesn't. I'm going to toss out the negative 8 and keep the 5. Length equals 5. So that's part of the answer, to find the dimensions of. So the length equals 5. If I know L equals 5, and then over here it says width is 3 plus L, so width is 3 plus 5, or 8. So basically it's a 5 by 8 triangle. Now, I'm sure many of you are able to guess that, and that's great. And if the numbers are nice, then by all means you can go ahead and guess. But if the numbers are not nice integer values, you might not be able to guess. So it's important that you know this method. Number 8. A rectangle has an area of 28. A equals 28. Find the dimensions of the rectangle if the width W is 1 unit less than. Oh, I wrote the 1 too quickly. 1 unit less than. That means I'm going to have to subtract from something. Subtract then what? From what? 1 unit less than twice its height. Twice its height. Alright. Seems like we're using W's and H's here, so I'll say that 28 equals W times H, and W equals 2H minus 1. And just like we did in the last problem, we're going to do some plugging in. So I get 28 equals W, but instead of W, I'm going to write 2H minus 1. And then keep the H. And I'm going to distribute just like I did in the last problem. H times 2H is 2H squared. H times negative 1 is negative H. And then I'm going to get everybody on one side and 0 on the other. And I have to factor this. Now, this is got a term that is not 1, so these are a little more difficult to factor. If you like, you can totally use the quadratic formula. I know a lot of you would rather use that. But I have in the past, back in the fall, taught you a quick way to factor. And what you can do is you put an H in both sets of parentheses. Now we have to take care of that 2 in a minute. What we're going to do is divide the numbers that we would normally find by 2. Now we find the numbers that we need here and here by taking the A term times the C term. The A term times the C term, or 2 times negative 28, is negative 56. and 2 factors of negative 56 that add to negative 1, that add to the b term, are negative 8 and positive 7. So you put the minus 8 and the positive 7 in where you normally would, but I do have to add this 2 and divide those numbers. So I get h minus 4, or 7 over 2 is 3.5. And we set those equal to 0. We get h equals 4. And h equals negative 3.5. And of course, that doesn't make any sense. We've got to throw that one out. So I got h equals 4. Now they wanted the dimensions of the rectangle, so that's part of it. H equals 4. But I also need the width. And the width formula was 2h minus 1. If I copy that from above, if I plug in h, I got 4 minus 1, 8 minus 1, which is 7. Width is 7. Now, again, I know that you could guess that if you played around with the numbers. The numbers will not always be this nice, so I need you guys to be able to follow this procedure for when the numbers are not quite as convenient as the ones you've been provided. Hope this helps.